All right, now I'm going to just sort of show some of the details, a couple of the details I left out in example 6.4. And I mentioned that we needed to use some trig identities to rewrite expressions in the integral. So the first expression that we're going to work with is this one here, right? This showed up inside the square root of the integral in that example. And I said we're going to use the product to sum formula. So there are two product to sum formulas that we need to use. There are actually three product to sum formulas, but we just need to use two of them. And product to sum meaning what happens if we're starting out multiplying two sine functions like sine mt times sine nt, and how we can rewrite that as a sum or difference of trig functions. So the product of two sine functions we can write as a difference of cosine functions. So if we start out there, in this case, I guess m would be 5 and n would be 1. So this would be 5 minus 1, there's 5 plus 1. So this, our first step here, this would be minus 2 times, and then using that first product to sum formula, we have 1/2 times cosine 4t minus cosine of 6t. And for the second term, this is a product of two cosine functions, so we'll use the second product to sum formula listed, so that'd be 2 times 1/2 times, and m and n are still both 5 and 1, so that'd be cosine 4t plus cosine 6t. So if I distribute, so the 2 times 1/2, obviously those will cancel, and then I'm going to distribute the negative through each of those parentheses. So we have a minus cosine 4t plus cosine 6t. And then over here we got a minus cosine 4t minus cosine 6t. The plus cosine 6t and minus cosine 6t cancel, so we end up with minus 2 cosine 4t. So, in that example, when we were looking at 2 minus 2 sine t sine 5t minus 2 cosine t cosine 5t, that is just equal to 2 minus 2 cosine 4t. The other identity we needed to use was to simplify this expression in the radical that we have now, 2 minus 2 cosine 4t, and to do that we need to use a double angle formula for cosine. Now there are three versions of the double angle formula for cosine. They're all equivalent to each other. Technically, no matter which one you start with, you could still get to the same ending point, but the easiest, the most straightforward place to start is to use this version, that cosine 2 theta is equal to 1 minus 2 sine squared theta. So now I'm going to use that on this expression here. So, and I'm using this double angle formula, I'm going to use it on cosine 4t. So that's 4t is my 2 times theta. So 4t is 2 times 2t. So when I use the double angle formula now, this is 1 minus 2 sine squared of 2t. And now I'm going to just simplify. I'm going to distribute, right? So I got 2 minus 2 plus 4 sine squared 2t. 2 minus 2 is 0, so we get 4 sine squared 2t. And that was the other simplification that we used.